Okay, so let's get started. The week before last, I did a presentation on ChatGPT, just kind of general impressions, kind of an overview. And then in the 2 weeks since then, I started doing some experimentation to see if I could use ChatGPT for a more specific purpose, and that was to build some tools, right? Create some tools, again within the umbrella of mixed model manufacturing. So I wasn't trying to create tools for some random thing. I was trying to, develop things hopefully that would be useful for this domain of assembly line design or value stream design and material delivery. Those are our two wheelhouses or areas of expertise. So what I'm going to be doing here is reporting back to you what I accomplished and maybe some difficulties I had, some lessons learned in terms of getting involved with ChatGPT to do this. But overall, general impression, just a spoiler alert, I'm really excited about this as an opportunity, right? So here's the agenda for today, and this should last about an hour or so. So first one, I want to share with you some of my case histories of my own career, where developing these types of tools, I think was a very positive for my own career. Because what we're talking about here is not developing ERP systems or some kind of major software, or even being a software specialist at all. It's just being, in our case, a lean manufacturing specialist, but with some skills to do things and make things more efficient and make a contribution to eliminating waste in many times from our organization with small tools. So I'll share with you some successes I've had, which I think have been really positive. We'll quickly review the mixed model methodology, the umbrella that we're talking about, the scope of the kind of tools that we'll be talking about here. And then we have 5 tools that I've worked on. First one is family definition. I'll explain later what these are in more detail and why they're important, but basically product family definition or process commonality might be another way of looking at it. Line balancing, that's critically important. Whether you're lean person or not, it's still an important topic. Resource calculations is an integral part of our methodology. Sequencing rules, so the order of production, how you develop those rules, and then how you manage those, once you're up and running. And then we have the building of simulation models, which we're a big fan of. And so anything we can do to speed up that, sometimes it's a difficult step, a process, the better. And then we'll have some summary of lessons learned. So I think this is going to be a really good one. I'm looking forward to this presentation. So first, what is ChatGPT? I have a poll here. So I'm going to turn it on. Last time I wasn't successful because I think I closed it out too quickly. But I have a poll here that I'm going to open up. And you should be able to see it now. Tell me if you can't in the chat box. Jeff, yes, it's being recorded. So you can come back to it if you have to leave earlier. I'll send out an email to everyone on the list with a link to the replay. So I have a poll in terms of your background experience with ChatGPT. So if you can see it, let me know in the chat. Someone? Not yet? Okay, so maybe I have to turn it on. Hold on. It says publish. All right, so I published it. So you should be able to see it now. Yes, okay, it is working, no problem. Right, so I'll leave it open for a bit so we can get feedback. So what it is basically is an AI tool, language-based, almost like a chat box, so you can submit questions, queries, challenges, ask it to write code, etc. And it's it's pretty remarkable in terms of what it comes back with. There's a free version, there's a paid version. I think the latest one available to us is GPT-4, which is the one I've been using. So I have a paid subscription, but it's not very expensive. I think it's $20 a month for the paid version. And when you think about it, you're paying for access to this massive super brain, superhuman capabilities in a lot of areas, which is not a bad deal, right? So I'll be using ChatGPT. By the way, ChatGPT also has an API, so meaning you can connect with it with an external application of some kind. And so there are hundreds, literally hundreds of specialized applications that are tapping into ChatGPT. I don't know if that's a good thing or not, but that's happening. The horses left the barn, as we say. So there are lots of applications that are using this. But for this presentation, I'm using straight vanilla ChatGPT, right, to ask what they call prompts, right, or scripts or queries. The other thing, the caution I made a couple weeks ago was that that AI or ChatGPT is subject to hallucinations, and that means that sometimes the answers you get are flat out wrong, and so you have to be cautious of that. But what I've discovered, I think, or learned, and again, you can't rely on this, but when we're asking very specific questions, it tends to be pretty good. And when you ask more vague or general questions or philosophical questions, then it tends to get lost sometimes. So in this case, I don't think I ran into any hallucination because I was asking it to do something very specific, right? And yeah, I haven't had much of an issue with that. But you do have to take everything with a grain of salt. Okay, so the poll is up and running. This is a DALL-E image, and you can see some of the challenges that are still there. I think it's actually gotten better, and there's some other, image creation alternatives to a DALL-E, which is the one I was using. But you can see here the guy on the top has 4 fingers, and I think you'll find other people with 6 fingers, and one person doesn't even have a hand at all. So, it has some issue with those, but I really get a kick out of DALL-E and the kind of images that you can create. So, well, I'll just leave the poll up for a little while, and then we'll look at the results. Okay, now using ChatGPT or building tools as a career boost. Let me share with you, and this is another one of those DALL-E images. Let me share with you some of my experiences. There are two that come to mind. First one was I was working for a lean consulting company. So that's what we were doing. We had a pretty big team. This was my first lean job as a consultant. And we had a pretty big team, and we had software that we were actually using as well, specifically to do Kanban calculations and print Kanban cards, Kanban management software, basically. And so when we would engage with a new client, we would have to ask for data so we could load it into this database, this Kanban database, and do all those things. So invariably, without exception, I would say, the files that we would get back to them, even with what we thought were clear instructions, would not be right. There would be something wrong with the format or the data, or something was wrong. And so then, we typically, as a team, did not have the technical expertise to look at that data file and fix it. So we would have to kick it back to the client and say, hey, this is wrong, you go fix it and send it back. And of course, every time you had to do that, there would be delays. And so they would just delay the program every time, virtually. So I happened to have, I was, I think, unique among the team. I had some experience with DBase, and specifically with the DBase compilers called Clipper. So I could take data and load it into a DBase table or tables. DBase was not a relational database. It was just a series of flat files. So if you wanted to relate them, you had to do that manually. But I knew how to do that. So I created a tool for our team that would take that data input file from a customer and load it into DBase and analyze it, right? Go through it and check for errors, kick out an error log if there was some information we couldn't fix. And then when we were done with the errors, it would print out a perfectly formatted data file that could be loaded into our software. So that was a huge help. I think that, that increased my stock with the company of being able to provide that for the team. And again, this was not a major system. This was a tool, right? But it was with Clipper, you could create an executable so everyone could have their own copy on their little laptop, and we could even give it to the client, give it to the customer. They could use it themselves. So that was a big plus, in terms of, I think, in my career. Another one, which was prior to that, was line of balance. So I was working, this is my pre-lean career. I was working for an aerospace company, and a lot of our business was projects. to be delivered over a X number of months. It was an aerospace company. So typically it would be, deliver 3 units a month for the next 12 months, that kind of thing. And the processes were quite long, a lot of them. Some of them involved external processing, internal curing times, all kinds of things like that. So what the challenge is that if you lost track of the pipeline, because the processing time was not a few days, it was months, right, to finish one of these individual products. And you can see down in this exhibit here, kind of the timeline, kind of a value stream map of how long it would take. A lot of parallel work happening. So if you lost track of any part of the pipeline, you could be delivering on time, but if you had lost track of a previous process and you were behind, then you were going to be behind when it came to deliveries. So it was important to understand the entire pipeline, the entire value stream, and not lose track of any of those pieces. So a great tool for that was called line of balance. If you're not familiar with line of balance, if you're a manufacturing engineer type person, look it up. It's really, really great. But there was no software available for it. It was just a concept or a method. And so I developed, again, a tool that we could use in the company, again, based in DBase and Clipper, because that's what I knew. That was kind of my expertise. And it worked great. And we were using it on basically all of our repetitive projects. Now, some of the projects we had were one off, but a lot of them were, multiple deliveries over a certain period of time with a long lead time. So when I left the company to become a lean consultant, I went back about 5 or 6 years later for a visit, to see my old friends and check in, and they were still using it, the line of balance program. So I doubt they're using it today, but at least it had some longevity even after I left. So again, big career boost. Now let's quickly talk about mixed model line design, because that's kind of the umbrella we're talking about. So here are the basic milestones of a line design project or a value stream project. So we have a planning stage, we have a collecting data stage, we have a calculation stage or data analysis calculation stage. Then we have a simulation modeling stage, which we recommend. Some people skip this, but we recommend you don't. And then we have a deployment stage where you have to do a final CAD layout and then actually, make it happen, build the line or buy the equipment, and actually start building products. So how does this relate to our opportunity with ChatGPT? Well, let's take a look at that. Basically, there are opportunities at every one of these stages to use a tool like ChatGPT to develop tools, right, to do this stuff better. And we're going to be looking at many of these in this webinar. So I just, added some observations or brainstormed, a few opportunities. For example, ChatGPT, maybe now or maybe in the future, could actually create value stream maps. In other words, you could develop a prompt or description, and then it can generate the actual value stream map. And maybe not so much now because it's totally text-based, but certainly in the future. So value stream mapping would just be describing, in English and letting the mapping part of it be done automatically. Also, taking a value stream map and analyzing it and identifying opportunities from a lean perspective for improvement. Now, we can do that manually ourselves, sure, but maybe we miss things or maybe it takes a long time. So that could be automated. And also the deployment plan for this entire project that you're seeing here could all be understood by AI, and a detailed time-phased plan could be created in 60 seconds versus spending sometimes days on it. So I don't think I'm going to take time to read through this. You'll be able to get a PDF of this presentation so you can see some of the ideas, but we're going to be talking about some of these in this webinar, since we typically run out of time. So I want to get going. All right, so here we go. First one I looked at. And again, one thing you're going to think maybe is when you see some of these tools I developed is, well, yeah, but that's really easy to do manually. And you would be right in some cases. But something that seems simple with 10 products could be a lot harder if you have 100. So there may be even opportunities here. So use number one, product family analysis. So what we're talking about is when you're designing a mixed model line, remember that's our umbrella, you're going to want to mix or combine or build different products on the same line. So we call that a product family. So a simple example would be cars. You have different options on the cars. You may have different models on the same line as well. I think Toyota in Georgetown builds the Camry and the RAV4 and maybe some other models, Corolla, I'm not sure, on the same assembly line. Or air conditioners. I had a lot of experience in that industry where you have a lot of different models, different capacity sizes, but it basically goes down the same line. So variation in process and process time is pretty much inevitable, but there are 3 hurdles you want to overcome to make sure you have a good family. Because if you don't define that family correctly, then you're going to have problems in executing, right, in running the line. And the first one is process commonality. So we have to have not 100% the same processes, but pretty close, right, within a pretty narrow range. And then process times. You can't have one product that takes a minute and another that takes 15 minutes. That would not be easy to mix. The process times would be too different, too much variation there. And then the third thing is materials. So if you have zero material commonality from one to another, then you're going to have problems with just material delivery. Not impossible, but you just should be aware of that, as you go forward. So what I did here was I created a tool to address the first one, the level of process commonality, to assess the level of process variability. And this is a method that we teach in our workshop, in our mixed model line design workshop. And I've just automated it, basically. So here's an example. I'm going to be using this bicycle factory, which is the same example we use in our mixed model line design workshop throughout this webinar. So what we have here is what we call a process flow matrix. And we call this sometimes the X matrix. So what you're seeing here is a list of products on the left side, list of processes across the top, and then if that product requires that process, we put an X. And you can see here that there's some variation, right? Not everything goes through exactly the same flow. There's some differences. And that can happen, right? You can have optional processes that are only used on certain products in this family. So we want to know that. And so our goal here is to be able to mix this, sort this, I should say, into groupings that are identical. So we can see how many products have exactly the same flow and maybe color code that. So that's what I'm going to do here. I am going to create a script, or I created a script. So this is in English. So I wrote this out with Word, right? Opened Microsoft Word, and I just described what I want this tool to do. And that's basically how ChatGPT works. So 39% of you in the poll have not used it yet. So you can get a free membership or access to it, and you can try some of this out. So you create a script and you describe what you want it to do. And in this case, I want it to create a macro, right? An Excel macro. And in that macro, I want you to look at this worksheet that we created, and I want you to do the following things, right? So not too tough, right, to write this out. Now, here's a tip for you. The more specific you can be, the more you can think this out ahead of time and describe what you want to have happen, the better results you're going to get, because otherwise you're going to be getting not exactly what you want, and then you're going to be going back and revising your script or your prompt, and then you're going to be running it again and going back and forth and back and forth. Now, some of that's inevitable that you're going to have to do that, but the more specific you can be up front, the better, the more mature result you're going to get from ChatGPT. All right, so I have here, I'm always worried, I'm always worried about running demos live. So I created a video here on a family definition. So I'm going to run it, and it has an audio. So let's see if this works here. I'm going to run the video to show you this this tool. Okay, let's go. Here we go. So this is the first and probably the easiest experiment with ChatGPT and creating macros that I did. So what we're doing here is looking at a matrix of part numbers or products on the left side, and volumes. We're not really using the volumes, but that's there. And then we have across the top a list of processes, and an X if that product requires that process. So you can see that not everything's the same. Not every product requires every process. So for example, men's modern bicycle, these are all bicycles by the way, and women's modern don't require, in our design here, spoke insulation, so no wheels basically. And that doesn't mean that the bicycle doesn't have wheels, it just means that we buy the wheels because they're somehow different. We're not able to manufacture them ourselves. So there is some variation in terms of the processes required and the volumes going through those processes. And what we want to do is analyze this. Now, this is a simple one. It's only 10 products, but it could be 100, right, or more. So what we're going to do is sort this list by process commonality so that we can get some idea of the level of process variability, which can make a big difference in terms of how our eventual line is going to perform if we have too much variability. So we have a method that we teach in our mixed model line design class, and no threats, that's good. And so we're going to apply that method in an automated way by generating a macro that will basically sort this list in an accurate way. So I'm going to go to macros. I'm going to view them. I'm going to select the one that is sort by family, this one. Again, this is a ChatGPT macro based on a script that I wrote describing how we want it to work. I'm going to click on run, and boom, there we go. So what it did was every time it found an X, it converted that X to a value, 1, 2, 3, 4, 5, all the way across, and then it increased that value by the power of that same number. So 1 to the power of 1 is 1, 2 to the power of 2 is 4, and then 27, 3 times 3 times 3, and 4 times 4 times 4 times 4, etc. And then it added up all those numbers to get a total, and then it sorted this list by that total. Now, why did we do it in that somewhat, seemingly strange way? Well, because by doing that, it guarantees that we're not going to have combinations of processes that add up to the same number but are not really the same process flow. And this I don't think this guarantees it 100%, but pretty darn close, that you're never going to have that situation come up because the differences are so big between one process and another in terms of the numeric value. So you can see here we have 3 different flows, and then again, as a designer or as a manufacturing engineer, we would need to look at this and determine whether any of these are going to impact the performance of our line or not. Now, again, with 10 products, it's easy. With 100 or 1,000 products, this could be very useful as a tool. And so this is where we started. And I'll show you in the next slide kind of what the code looked like and what the prompt looked like. All right, I keep forgetting last time to turn my microphone back on, but I think I'm back there, back now. So let's pick up where we left off. Okay, so we created a script. We looked at how it worked. This is going to be way too small for you to see, I think, but basically you'll be able to see it in the PDF if you want to download that. But here's the script, and then here's the macro. And what you do is you just copy that macro into Excel and run it. And I've had pretty good luck at not getting any errors on macros, coding errors. Once or twice there was some strange thing, but pretty much it does what you tell it, but you need to tell it very precisely. Okay, so that's it. So sort, and again, if you had 100 different products, you could see this would be kind of handy because trying to sort it all manually could be kind of a pain. In this case, it happened as fast as you saw it, right? It's like instantaneous. it sorted it, and it color-coded each family together. So that could be a useful thing to have. Let's go on then to the next one. And I understood that maybe you were getting some funny audio on the video. I think that was because I didn't mute my microphone. So we'll make sure we address that. Next one is line balancing. So line balancing is if we have a process, let's say final assembly, and you want to design an assembly line where the first station does a portion of the work and then hands it off to the next person, then line balancing is the task of taking the individual work steps and trying to allocate those to the different workstations as smoothly as possible, as even as possible. So here's a typical standard work definition form. I mean, there are different, if you work for a manufacturing company, you probably have your own version of this. And this is the one we use. I'm not going to go into a description of all these column headings, but we're mainly focused on the times here. So we have the total time for this process. Remember, we need one of these for every product and every process. So this is a product process combination, and we have the times to assemble a bicycle. So this is not building the wheels or welding the frame. This is just assembly, right? Final assembly. You got all the parts and you're putting it all together. So these are the times. And when we build an assembly line to assemble these bicycles, we're going to have a certain number of workstations. Now, here's an important point, a mixed model manufacturing point, which may be new to some of you. Normally, we think in the lean world, we think of takt time and balancing the work to the takt time. So every station does a takt time worth of work, and then moves it on. That won't work in a mixed model environment because the work content can vary. And if we try to balance all the products to the same number, then you're going to get some products that are going to be done before you get to the end, and there are going to be other products that you get to the last station and you still got a lot of work to finish. So that methodology of balancing to takt time simply is not going to work. So what we're going to do instead is we're going to calculate how many stations we need based on a weighted average work content. And then we're going to balance to the number of stations, not to the takt time, right? So that's an important thing to understand here. Right, so there we have our standard work definition. So again, created a script of what we want it to do, and then it created the code, right? The VBA code for Excel. Copy that, pasted it in, etc. So let's see how this works. So this is tool number 2. I'm going to go back to videos and line balancing. Let's start it. Okay, so here's a standard work definition for a specific product. Up here, standard mountain bicycle, and a specific process, final assembly. So we would need one of these standard work definitions for every product and process combination. Now, we won't go through all the column headings here and what they all mean, but we're primarily interested in these times here, process times. And what we want to do is, because this is the time for the total process, if we want to do the work in a sequential way where, like an assembly line, the product is passed from one worker to another, we need to balance that work or divvy the work up for each workstation. So this is something that could be done by hand, but you can imagine if you had 50 process products combinations to analyze, that could take a while, so we could use a little help. So we've asked ChatGPT to help us with that analysis and doing basically a first pass of line balancing, which will still need to be reviewed by a human being, but maybe can speed up things a little bit. So here's what ChatGPT helped to develop. I'm going to go to View. I'm going to go to Macros, View Macros, and we've created one called line balancing right here, a macro called line balancing. So I'm going to run it. I run it, and it asks me, well, how many stations do we need to balance to? That number is going to come from our resource calculation, the static resource calculation that we did previously. So we're going to rely on that calculation and put in a number. Let's just say, for the sake of a demonstration here, we have 5 workstations. So we're going to have an assembly line with 5 stations. So we say OK, and then it gives us a little bit of feedback. It tells us the total time for this particular process and product combination is 8.5 minutes, 8.5 minutes, and then our time target per station is 1.7 minutes. Now, what we've done in the macro is allowed some range, so that if the work time fits within that range, then we're calling it a station. So we don't expect to be able to hit the 1.7 minutes precisely, but we want to get pretty close. So we say OK, and it found the first one, right? So first one is highlighted in blue here, and it says workstation ends at row 14. The station time is 1.6 minutes, so slightly less than that time target. Then we click on it again, comes back, workstation ends at row 21. The station time is 1.8 minutes, so it's slightly over. And then we have workstation ends at row 29, 1.8 minutes, 1.7 minutes, and then we have a final station with 0.9 minutes, so we're significantly under there. So maybe we could find some other tasks for that last station to do, to take advantage of that extra time that may be available. So there we go. It's created this initial first pass. So again, I'm not saying this we could go to work on this directly. We'd want to have a human being review the steps, make sure they all make sense, and that the handoffs all are reasonable. But this would save, some time. So that is the ChatGPT tool number 1 that we've created. Okay, that was ChatGPT tool number 2, right? Not number 1. Okay, so let's continue on. All right, so that was the line balancing tool. Next one, resource calculations. I think we're doing pretty well on time. So we typically will build a line design calculation worksheet. This is after the data collection phase, where we have time studies. We have a lot of data we can work with. We're organizing it. And the goal here of the line design calculation worksheet is to calculate how many stations do we need for each process, or how many people, how many machines, if machines are involved. So it's a resource calculation, and it's a static calculation. It's an Excel spreadsheet typically. So what you see here is the same 10 bicycles and the same processes we've been looking at previously, and the volumes. And then we have, instead of an X, we have the actual work content time for in that process for that product. And in some cases it's the same, and in other cases it can vary depending on the product. So the times don't always have to be the same. So down here at the bottom, we're doing some data processing calculations where we calculate the volume going through that process. In this case, these blue ones here are all wheels. So we have 2 wheels on a bicycle, I think. So we're doubling it. These are the times for 1 wheel. And so that's our volume. It's twice the number. We have twice the number of wheels compared to bicycles, right? That makes sense. And then we have available work time. So this is an estimate or calculation of how much time do we have working, not getting ready to work or taking lunch breaks or taking breaks. It's, on the line working. So 840 minutes in this example. So then we can calculate takt time, which is, the time per individual unit. So that would be the 840 divided by 1318. So simple arithmetic. And then we're calculating the weighted time here, the weighted work content time based on the volumes. So the volumes are not always the same. So we're going to weight the higher volume products more heavily than the ones that are lower volume. And we get in this first column here, the first wheel process is 1.03 minutes per unit. And then this is a simple calculation of the standard time weighted divided by the takt time. And that'll tell us how many resources, 1.62. The final row here is how many workstations, if this is assembly, workplaces or workstations do we need? We can't have 1.62, we would have to have 2, right? So this would, again, determine how many physical locations we're going to actually have in our line design. Great, so that's that. So what I did was I tried to see if can we just automate this whole bottom part. If I have the data, then this is subject to making mistakes, and it just takes time to build this. So let's just automate that whole part of it. So I described a script here. So create a VBA macro following these step-by-step instructions, et cetera, et cetera. By the way, side comment, one thing you can do if you're going back and forth with ChatGPT and developing the macro, kind of on a step-by-step basis, is at the end, once you have what you want, you can ask ChatGPT to create the prompt or the script. You can say, please write for me the perfect script to create the macro that you just created. And it'll give you a cleaned up, concise script. And that's what I've been doing. So sometimes I have to make changes, make corrections, et cetera. It's kind of an iterative process. But once you're done, just let ChatGPT give you the perfect answer in terms of the script. And that's what I'm saving as my script. I think that's a pretty good tip. All right, so let's look at how this would work. I'm going back to videos, and we're going to do resource calculations. So let's play the video. So here's our resource calculation worksheet. And just a quick review of what we have here. We have our products. This is our bicycle factory example that we typically use in some of our workshops. And we have the volumes for design purposes. We have process times. That's the total time for that product and that process. And then we have some calculations that take place down below here. So we have the total volume and the multiplier. Like we have 2 wheels, for example. This is a wheel process. So we have a multiplier here that we would need to apply. And we have process volumes, available work time. We can calculate takt time then per unit. Standard time weighted based on the possibility of time variation by model. So weighted average time. And then how many resources, that would be workstations or people. And then we'd have to round up typically. We can't have part of a workstation, so that would be a decision we'd have to make whether we round up or round down. So what we're trying to accomplish here with this macro is we can't get away from having to gather this data, but maybe we can just automate this bottom portion of the sheet. So what I'm going to do here is delete this. So let's assume that this is all we have here is the data, which is not a minor detail, right? We've collected that information, but we want to then do the calculations. So I will go to View Macros, and we have one called Resource Calculation. Cleverly named Resource Calculation. And so let's see how we do here when I click on Run. All right. So far so good, and now it's prompting me for some information. So the available work time, that's something that we could have entered here previously, but we're just being prompted for it here. So that's, 1 shift, 2 shifts, and how many minutes of those shifts are available to actually do work. So I'm going to type in a number, say 2 shifts, 840 minutes. We say OK, and boom, it completes the worksheet population. And the only thing it didn't actually complete were 2 things. One is it just defaulted to 1 as the multiplier, but in this case we have wheels. We need 2 wheels per, so that's a manual change you'd have to make. And you'll notice that it populated down here wherever appropriate with formulas, not with actual values. So if you make changes like that, where you go from 1 to 2, it adjusts correctly, as opposed to just doing the calculation in the macro and then populating a number in here. It's actually putting in a formula that you can see here, which is kind of necessary. And then down at the bottom here, we have a blank row, and this would be a human decision that you'd look at. So I need 1.62 resources. That would be workstations, let's say. So I would need, pretty clearly, I would need 2 in that case. 1.13, do I want to round up or round down? Well, if you're within a certain range, you might want to consider improving the process or looking at opportunities to not round up and just round down. So we'll just say we'll round up here, here. Can't have less than 1. Here, that's pretty clearly 5, 2. This maybe we'll try to round down, right? Maybe we have some sense that we may be able to do this. This is a machine, so we're going to treat this a little bit differently. I'm just going to put in one here. We're not going to have 30 or 29 machines. We'd have to look at the capacity of those machines and so on. So this requires a little extra different work. And then powder coating, I need one powder coat line, one here. I'm going to round down, one here, 7, 1, and I'll round up for pack. So that's the only manual piece you would have to do here. So again, not a huge deal, but by standardizing the calculations, it makes sure that every time you do it, you're doing it correctly, right? Because you've embedded that method and the formulas into a macro that you're just reusing. So could be quite useful to just save a little bit of time and reduce errors in terms of this particular important step, right? So that's that. All right, so let's continue on. I think we're doing well in terms of all these cool things. All right. Next one, developing sequencing rules. So the issue here, I put a quote in here, challenge. This was one of the ones where I think it's really valuable. And I'd done some work on this pre-ChatGPT. But when I started, I think it's possible with ChatGPT to do this, but I kind of ran out of time. But I wanted to show you what the challenge was, or how this works. So I have a video that describes what I actually was able to do manually, but I want to continue working on this and get ChatGPT to do this for me. So here we go. So here's a demonstration of an Excel-based macro that I created manually with the intention of trying to get ChatGPT to kind of duplicate it, replicate it, figure out how to do that. I'm going to call this, I wouldn't call it a fail. I'm just saying this is a challenge because it's a little bit more complex. So I haven't spent, I'll have to admit, not a lot of time on this, but it does work in the version that I was able to craft over many days, I'll have to admit, myself manually. So let me explain how this works. What we're trying to do here is create a sequence. Here's a sequence worksheet where we list the products and then we list the quantity or the number of units that we want to run in this order. So we want to build 2 of this model and then 5 of these and then 12 of these and then 3 of these, etc. And this would be an input then to our lean design simulator so we can measure throughput and productivity or utilization of people and machines. So the idea here is that we need a way of approaching the development of sequencing rules scientifically, logically, and not taking a lot of time. So what we have here is an input worksheet to create various scenarios. Again, with the understanding that Lean Design Simulator is not going to tell you what the answer is, what the optimum answer is. It's going to show you what would happen under various scenarios. So the idea is that we would run experiments and try to get closer to an optimum sequence of products to maximize throughput and productivity. All right, so what we have here is, again, this is our well-beloved bicycle factory. So we have these models, these 10 models, and we have demand. So these are the quantities that we're going to want to sequence. And that could be a daily mix, or it could be a yearly mix. Well, that would be a lot, or a monthly, weekly, et cetera, whatever we want to do. But this is the mix of products. So it's not the same quantity of each of these models. Some of them are high runners, high sellers, and others are more, specialized. So we have the demand number and then the order. So the order is which one of these models is the one that we want to sequence first. Just to picture a blank sequence worksheet, and we want to try to lay out the order of production for the the first model first. And it could be we want to run all 78 as a batch. I mean, that's an option. But if we want to do a mixed model manufacturing where we mix these models in with other models, then we have a chance to manipulate that here. So the order is the priority, basically. We're going to sequence the first one, whatever's number 1 first, and then number 2, number 3, number 4. Clearly, when we get to the last one, we're just filling up any empty slots we have in the schedule. And by the way, this methodology is one that was presented by a professor in Germany named Christoph Roser. And he had a series of blogs on his website called All About Lean, which I recommend, where he describes this approach. So we set the order, again, the order of step-by-step analysis of the sequencing, and then we have the lot size or the quantity that we want to run. So again, that could be one, and then we'll mix in others, or it could be small batches. And then the ones in gray, the columns in gray here are calculated. So it's not those are not input columns, but the repeat means how many times during this schedule would this particular model be repeated. So we're going to have 39 instances where we're going to be building the W0326. And then interval is how many units between, in the schedule between units would we normally be running this W0326. In other words, we run one and then it's going to be 18 takt times or 18 cycles later when we would run another one. And then spacing allows us to kind of fine tune the scheduling. Spacing means there may be models where we can't run them or don't want to run them back to back. So if it's a spacing of 1, we could run it back to back, right? We could run one W0326 followed by another one. But if there are reasons why you'd really never want to do that, it might be a very high work content product, for example, where you wouldn't want to do that. Then you can specify how many units to skip in between before you would allow another one of these particular models. So it's additional refinement on the sequencing logic. All right, so how does this work? Well, we're going to go to a worksheet here, and whatever worksheet we're on, it's going to test to make sure the format of that worksheet is correct. We'll just use this one. Now, if you want to not lose your scenarios, you would just save this worksheet under another name, like sequence 1, sequence 2, sequence 3. But in this case, we're going to overwrite it. So I'm going to go to View. I'm going to go to Macros, View Macros. And we have a macro here called Auto Sequencing. That means it's going to prompt us for some information or feedback some information, but it's going to do it automatically. So let's run. So it says, hey, are you sure you want to delete all the existing data on this worksheet? Because it's going to erase it and start over. So we said, okay, yes. Data cleared, the macro will now run. All right, boom, we run. So it scheduled the first one. So it sequenced product number 1. And you can see we said there was about 18 rows between each one. And then it's going to run 2 of these and then 2 of these, et cetera, till we get to that total quantity we want to schedule for this one. So we could have it populate this whole worksheet in one step, but I just wanted to get some additional feedback, and so you can see what's happening. And then it's going to sequence product number 2, and then it's going to sequence product number 3 based on the logic. Now it's going to fill in here product number 4, number 5, number 6, 7, 8, 9, sequence 10, 11, or 10. There were only 10, right? So 10 basically is just filling in the schedule. So you can see here we have that quantity scheduled, or that number of rows, and that's it. So then we would run this sequence in the Lean Design Simulator and then record the results and run a series of experiments. So you could take some time running experiments, but I think this would be a lot faster, obviously, than
trying to develop your sequencing rules entirely in the real world, by actually building products, using the simulation model to help you get closer to a set of optimum sequencing rules. Right, so that is basically it. This is what I wanted to try to get ChatGPT to do, but I haven't, because of the kind of the sophistication of the logic. I think it's certainly possible, but it's something that that I'll have to be working on in the future.
All right, so we're back, and the idea here then, just if it wasn't clear to you, is we want to test the order of production in a mixed model line, because it makes a huge difference in terms of how that line is going to perform. So over time, and companies like Toyota, have done this for decades, but we want to understand the optimum sequence. So when we have a backlog of orders that we want to plan for or schedule, we know what the rules are for how you're going to organize that structure, that list of back orders, into the line to optimize throughput and optimize productivity of the folks working on the line. Okay, last one I want to talk about, simulation modeling creation. I'm just going to go through here real fast, but basically, let me tell you what the idea is. This is, again, a work in progress, but the idea here is to take our resource calculation worksheet here, one we saw previously, and just with one click, create a whole simulation model data file that's compatible with our simulation modeling tool, which is the Lean Design Simulator. So you don't have to build the model, step by step by hand. It can do it in about a second, right? Or maybe give it 5 seconds. It's going to generate the whole model. And I think that's possible. But the reason I didn't get it done by this presentation was there are a lot of steps. But I think ChatGPT is not going to have any problem in developing that. So maybe next time we talk, I'll be able to show that. And I'm excited about that. So we take our resource calculation static sheet and develop a dynamic discrete event simulation model in one single click. So excited opportunity. All right, so we're getting close to the end. Let me make a couple comments. In the future, some of you maybe have a programming background. Most of us probably don't. I don't per se, although I have some experience, with coding, but not a whole lot. I've never done it for a living or anything like that. But I have a sense that the next step, other than we've been looking at Excel macros here, but I think the next step is going to be Python, because ChatGPT will run Python code, and you can do a lot more with Python than you can with just Excel, right? And Excel macros. So I think that's going to be the next step. And so I gave it a try. Again, not knowing Python. Let me make that clear. I do have, I've been kind of kicking the tires a little bit. I even bought this book called, Python Crash Course. You can see how thick it is. So I have not made my way through that. And I don't know if I ever will. But there are some simulation library. There are all kinds of libraries for Python. It's just unbelievable. And ChatGPT knows them. So there are all kinds of possibilities with a little bit of Python expertise. Like, how do you take the Python code? How do you do some simple debugging? How do you use an editor, so you can run it? Those kind of simple things, which I think are learnable. This opens the world to all kinds of opportunities to develop tools that are, really powerful. And Python can read an Excel spreadsheet, and it can write an Excel spreadsheet. So there are all kinds of things you can do. I just don't have, right now, I don't have the expertise really to make that happen. So you can do the same kind of thing. You create some prompts or scripts. And I created one to build a simulation modeling software, standalone executable. And it did it. And I'm just kind of midstream, so I have nothing to show you yet. But I have high hopes for that. And again, I showed you this book. There's unbelievable amount of help if you want to learn Python, from YouTube videos to books to you name it, courses. So if you want to tackle that, that's available to you. Okay, final steps here, lessons learned. So this may sound weird, a little bit weird, but I kept asking ChatGPT to go back and change little things, and it kept regenerating, the code. And there was part of me that felt guilty, like like I was asking a human to redo something, redo it. And I have to keep reminding myself, hey, ChatGPT doesn't care, doesn't get irritated if you keep asking it to do it again. In fact, it says, sure, delighted, here you go. So I just have to keep reminding myself that. That's kind of a humorous thing. Okay, ChatGPT and Visual Basic can populate spreadsheets with formulas. So this is an important thing I hadn't realized. Maybe it was obvious to some of you, but when you ask it to create to populate a worksheet in Excel, you may not want that to be the answer. You may want it to be a formula, and it can do that perfectly easily. You just tell it, don't put a value in there, put this formula in there. So that was really helpful because I was building these tools, but you maybe wanted to use the tool later and make changes, and you wouldn't want an answer in there because you might change some other parameter and it wouldn't ripple through, right, and get recalculated. So that was an important learning thing for me, maybe obvious, right, to some of you. I mentioned this earlier. Ask ChatGPT to recreate the perfect script once you're kind of done with the tool. So that'll give you a clean script that presumably is in a format and concise enough that ChatGPT is going to like that and be able to duplicate or replicate the tool. Whereas you may have developed it through a series of steps and try this and redo that and take out this, etc. Once you're done, you can get a nice clean copy of the script. Okay, displaying fresh code can be a bit time consuming, but clearly it's a lot faster than doing it by hand, by trying to create a Visual Basic macro, unless you're really good at it. But even so, I still think it's going to be faster. But the issue here, the lesson here is every time you make a change, it's going to want to recreate the macro, which takes some time to scroll on the screen, etc. So the more precise you can be up front before you start asking ChatGPT to do things, the better, I think. Be aware of buffer limitations. So it'll only handle so much at a time. What happens is it reaches the end of its memory or buffer, and it'll stop sometimes if you have a very long macro. It'll stop, and then you can say, please keep going. But sometimes the format that it comes back in is a little bit funny. I think in the future this will be taken care of, right? We'll have a much bigger buffer to use, but for the time being, you have to be a little aware of that. And maybe if you have a bigger type project you want ChatGPT to do, you break it into smaller pieces, right? Lesson 6, some programming expertise seems to be necessary. So if you know nothing about macros, know nothing about VBA or Python, if you get to that stage, then you're going to struggle probably, right? A little bit. But I'll have to say the learning curve bar is way lower than not having something like ChatGPT. And I've heard people say that an experienced programmer is something like 5 times more productive in terms of lines of code. If you have ChatGPT or an AI tool like that doing some of the work. But you got to remember, you need to know something. Like you need to know, what do I do with this macro code? Where do I paste it? How can I do some simple debugging? Oh, and something I should mention too, if you make changes to the actual macro rather than going through ChatGPT, then you're kind of you're disconnecting your script from the actual tool. So you might want to at least keep that in mind. So again, if you start making changes directly in Excel to the macro, that could be fine if you don't need to go back to ChatGPT. But if you want to have ChatGPT maintain the integrity, of your macro, you'll need to go back and make the change in ChatGPT as opposed to making it directly, right, in Excel. Okay, so one thing, I'm excited enough about this that we're adding a section to our Lean Design Studio, which is kind of our repository of all things mixed model manufacturing. You can see I added it. I don't know if you can see this on your screen, but I added tools/AI. Used to be tools, but I'm going to take some of the things we just talked about in this macro and start putting them, each one of those individual tools as a little, some instruction. So you still are the owner of all of that.